Okay. So, before the break, we introduced the selection statement. We finished the rest part about selection statement. That is, we introduced how to use the conditional expression. We also introduced how to use the switch statement. And we also test whether you guys really read the final project descriptions and then share some ideas on the Slido. And after the break, we will enter a new topics, and this is a very important concept in any programming language. So if it is the first time you learn any programming language, you might want to spend some time to understand the concept loops here. And I would say the core about most of the programming is loops, because loops can help you to continue to enter to input data and then continue to generate data. And you can also use loops to do some repeat action in your code. Depends on condition. You can control how many loops you want to have. So let's check out how to create loops in C. So today, in this one, we have 3 things I want to include, and depends on the time, let's see whether we can finish the do statement today. But today, first I will introduce the concept of loops, and then I will introduce the statement in C that can help us to create different loops. That is iteration statement. And then we will introduce the first iteration statement in C, that is while statement. And then the next statement, do statement, is also iteration statement, and actually do is highly related to while statement. So let's start. So what is loops? So the meaning of loops, if you type on the Google search, you can see that a loop is a shape produced by the curve that bends around and courses itself. And it can also mean a structure, series, and process, the end of which is connected to the beginning. And in Chinese, we'll call the loop 回圈. So it's just like the end of the loop is connected to the beginning. So it's like a 循环回圈, something like that. So that is the meaning of loops. So why we need to have some loops in any kind of things? So actually loops happens a lot in our daily life. For example, if we want to create a program that can help us to make a cake, right? And we know that to make this delicious cake, we have 3 steps. And please don't ask me why only 3 steps can make a cake. But anyway, in this world, we only need to have 3 steps to make a cake. So so after knowing that, after we know the 3 steps to make a cake by our code, we can just write down the statement for step 1, step 2, and step 3, and let our computer to run the 3 statements in sequence. Then we can have a cake, okay? But how about I want to make 3 cakes? So and these 3 cakes are the same cake. So to do that, we can just copy and paste the same 3 statements and run 3 times, right? We can have the first cake like this, and then the second cake, the second set of the state 1, 2, 3, and then the third cake. So it's okay, right? Because I just need to copy and paste 2 times to make 3 cakes. However, if we need to make these cakes, it's kind of impossible, or you will be really tired if you need to copy and paste these 3 steps for 100 times, right? And you will feel like these memes right here. So it's a very a lot of work, and it's not a smart way to do it. So that is why, if we notice that in our code we have some repeat statement, we have some we need to repeat a routine. We need to repeat a same set of actions. Then we know that if we have these patterns in our code, we can make them into loops. We can make them into 回圈. So how to do that? So we need to make the loop using iteration statement. So C have 3 iteration statements. We have a while loop, do loop, and then we have the for loop, and we will introduce for loop in next week and through the pre-recorded video. So this is the general form of a loop in C. So we need to provide the name of the loop statement here. So it can be while, we can put it here, or it can be for. So a loop is a statement that can help us to repeatedly execute other statements. So this is the statement we will repeatedly run. So we can put the statement inside the loop. So we will say that this statement is a loop body because it is inside the curly braces of this loop statement. And every loop statement needs to have a controlling expression. So again, it's very similar with the selection statement. We just put the controlling statement inside the parentheses, and then it can help us to control whether we want to continue a loop or whether this loop needs to be stopped. So this is what the control expression can help us to do. And each time or each iteration, the loop body is executed. There are 2 things will be performed. So if this is the first iteration, this is the first time the loop is executed, the first thing in this iteration is to evaluate the controlling expression to see whether we want to continue this iteration or we need to stop this iteration. So if the controlling expression is true, then it's tell the loop like, okay, you can continue this iteration. So in this case, the loop will be continue. The statement inside the loop body will be executed. And if it is false, then the loop will be stopped. Then the loop will be terminated, and then the statement inside the loop body will not be executed. So that is the basic framework, the basic action for every iteration statement in C. So now let's check out how to use while statements. So this is the easiest way to set up a loop in C. So this is the general form of the while statement. So again, we have a while here. So this is so we write down the while in the place that we have the loop here. And we have the parentheses, and we have the controlling expression inside the parentheses to control whether this while loop will stop or continue. And then we can put the statements inside loop body. And if this is true, then the loop will continue and the statement will be run in your code. And if you have multiple statements, just like the if statements, you can put the braces here to make it as compound statement. So and I will say put the braces in C is a very good habit. So in the following case, I will try to put the parentheses even we only have one statement for the while loop. So this is the example of a while statement. So what this while statement will do is to compute the smallest power of 2 that is greater than or equal to a given number n that is here. So you can see we have n, and n is a integer variables, and the users or the programmer can store any number integer value into n. And then if I want to calculate what is the smallest power of 2 that is greater or equal to n, I can write down the for loop to help us to achieve this goal. So we have a while loop here, and then the controlling expression of the while loop is to determine whether I should stop the calculation inside the while statement, right? So when should we stop? It's actually, we can check out the requirement here. So the requirement is that the number I want to find is a power of 2, and the number need to greater than or equal to n, and then it should be the smallest number. So that means that as long as I found a number that is greater than or equal to n, I need to stop the loop, because that will be the smallest number for this purpose, right? So so in this case, I use the integer variable I to store the result of each calculation. So in the controlling expression, what I put it here is to test in each iteration that whether the value currently stored inside variable I is less than n. And if it is not true, that means that I can be greater than n or I can be equal than n. So that means that I is definitely not smaller than n. So that means that if this is false, then it means that we need to stop the loop. And then inside the loop, okay, so this is what I just talked about. So if I smaller than n is true, then the loop body, the statement here will be wrong. And then the statement is that I just multiply I with 2 and then store back to I to calculate the power of 2. And then after we finish the statement here, then the program will come back to the while statement and then test this controlling expression again to see whether the value currently after the last iteration, whether the value of I is still less than n. And if it is true, then we will continue to write this statement again and then go back to the while loop here and then test the condition again. And this iteration, this loop, will continue until the expression eventually becomes false. So if I is not less than n, then the return value of this expression will be 0, and then the loop will be stopped, and the float of your program will jump from here, will jump from here to here. So it will skip the statements in the loop body. So let's try to trace the loop when we have a number 10 for n. So what I mean trace here is that if you feel a bit of confused about, okay, how can I know when should I stop and what is the value, what is the latest value of I, then you can try to use this technique, trace. The trace is a good way to help us to understand the loops and what happens in each iterations. So let's check. So I usually I like to write down the table like this to trace different loops. And because this is actually a really simple loops. So maybe some of you think you don't need to trace to understand it, but you need to know for the program in real life. You might have a loop inside the loop, and then loop inside loop you have if and else and do different things. So when you have these complicated loops, sometimes write down a trace table can help you to debug and help you to understand whether the value in each iteration to understand whether each iteration perform everything correctly. So this is very important. And I will say for the midterm exam, you will also need to write down something like this. We will have some complicated loop, and then we will ask you to write down the value of different variable in different iterations. So yeah, so this is an important thing. So I hope you can practice this after the class. So let's chase this while statement together right now. So in this case, we have a while statement, and we assign 10 to n. And so let's see. For the first iterations, so the statement we have here is we assign 1 to I, right? And then after this statement, the value of I is of course 1. And then we go to the next statement. The controlling expression is whether I is less than n. And now we know the current value of I is 1. The value of n is 10. So of course, 1 is less than 10. So this is true. So the action of this loop is to continue. So when we continue, we go to the loop body here, and the statement, this statement is executed. So after we finish the statement here and store the number back to I, 1 multiplied 2 is 2. So the latest value of I is 2. Then we finish because this is the only statement for this loop. So after this statement, you will go back to the while statement here, and then test the controlling expression again. And of course, 2 is still less than 10. So it's true. Then we continue the loop. So you can just write down the next statement is 4. So 4 is less than 10. So we still continue. And the next iteration will make I become 8. 8 is still less than 10. So we continue until we reach this iteration. 8 multiplied 2 is 16. So 16 is definitely not less than 10, right? So that means that in this iteration, the control expression is false. So when it is false, the loop will be stopped and it will jump from here to here. It will just, the loop will be terminated. So the statement inside loop body will not be wrong if we stop the loops. So if you print out the latest value stored inside I after the loop, you will find out I will be 16. Okay, so this is an example of how you can trace a loop and to write down the change of the value in different in the variables. So this is another example of while loop. So what this while loop do is to print out the value of I, and then if the value of I is still larger than 0, the loop will continue until I is not larger than 0, then the loop will be terminated. So you can see if you run this code on your computer, you will see the final the printed message will be like this. So because we initialize I to be 3, then when we have this controlling expression, 3 is larger than 10, so the printed message will be like this. The value of I is 3, and then after that we minus I by 1, and then because 2 is still larger than 0, so the loop will continue until we have 1, because after we minus 1 from 1, the value of I become 0, and 0 is not larger than 0, so that is why. After this line, the loop is over, because it will just jump from this line to this line and print and run this printf. And sometimes the body of a while loop may not be executed adult if the controlling expression is false at the beginning. So in this case, we just assign the -1 to I before the while loop. So in this case, -1 is already less than 0. So this controlling expression will be false. And then so the loop will not be executed at all because this is false at the beginning. So you will just jump out from the loop and then print and then run this printf. So the output of this code will only have one line, that is while loop is over. Okay. So I want to use this. So let's check out this video here. So this video just illustrates the concept about the selection statement, the loop, and the sequence. So now you have learned the basic important things in computer science. So I believe you can understand this video easily. So let's check out this video together. It's a very short video.
Behind all of the software that we use on a daily basis, there's a code being run with all sorts of different terms and symbols. Surprisingly, it can often be broken down into 3 simple programming structures called sequences, selections, and loops. These come together to form the most basic instructions and algorithms for all sorts of software. A sequence is a series of actions that are completed in a specific order. Action 1 is performed, then action 2, then 3, etc. until all of the actions in the sequence have been carried out. A sequence we do every day is a morning routine. You might wake up, drink some water, take a shower, eat breakfast, and so on. Everyone's routine is different, but they're all made up of a sequence of various actions. Selections are a bit different. Instead of following a specific order of events, they ask a question in order to figure out which path to take next. Let's say you go to brush your teeth and you find that you're out of toothpaste. You'd then ask, do I have any more toothpaste? If the answer is no, then you would add it to your shopping list. But if the answer is yes, then you would just use the toothpaste. This is really all a selection is doing, answering a question based on what it finds. The third programming structure is a loop. Like selections, loops also ask questions. However, the difference is they ask the same question over and over and over again until a certain task is complete. For example, take the act of hammering a nail. Even though you may not realize it, you're constantly asking yourself, is the nail all the way in? When the answer is no, you hammer the nail again. You continue to repeat this question until the answer is yes, and then you stop. Loops allow programmers to efficiently code repetitive tasks instead of having to write the same actions over and over again. These 3 programming structures may seem fairly simple on their own, but when combined, they can create some pretty complex software.
Okay, so I hope this short video gives you a concept about the sequence, selection, and loops. So I will say basically all the programming, no matter how complex it is, they are actually made by these 3 basic programming structures. So it's very important to understand them, and the other thing, just the applications or extension of these 3 basic structures.
Behind all...
So it seems like we still have some time to finish the do statement. So the next iteration statement is a do statement. So actually, do statement is just another version of the while statement, I would say, because the do statement is that the controlling expression is tested after each execution of the loop body. So the do statement is like this. We put the do here, but unlike the while statements, we have the while statement at the end. So we put a while statement here, and then again the control expression is here and the parenthesis here. So one very small but important difference between the do statement and while statement is that there is no semicolon after the while statement, right? Because you can see that in this while statement, we don't need to put a semicolon here or here, right? But in the while statement, in the while in the do statement, you need to put a semicolon here. So this is a small but important difference between the do and while statement. So if you write down do statements, you put the do here, and then the braces here, and then you put the statement here, and then you put the while control expression here, and then add the semicolons. So you can understand the do statement like this. It's just like to tell the computer, do this, and then test this, okay? So just tell the computer, just do this, and after you finish the statement, and then you can test whether I will continue to do the same statement again. So when the do statement is executed, you can see that just tell the computer to do this. So the statements inside the loop body is executed first. And then after we finish this statement here, then the controlling expression for the while will be evaluated. And then if this is true, then this iteration will go again. We'll go back to do and then do the statement again, and then test the controlling expressions. So the biggest difference between do and while is that the do statement will do the loop body first and then test. But for the while statements, the controlling expression will be test first, and if it is true, then the statements in the loop body will be executed. So you can actually try to compare the difference between while statements and do statement like this. So you can see that these two things produce, this while statement and do statement have the same printout information, right? Because here I have the value 5 for I, and then the test condition will be whether I is still larger than 0, and in each statement I just decrement I by 1. So you can see that the output is identical for this case. However, if we change the value of I to 0, the output will not be the same, because the biggest difference is that for the do statement, the do statement will perform the loop body first. So although here the control expression is false, but we will do the statement no matter the result of the controlling statements in this case, so that you can see the output information for the do statement we still have one printed message from the loop body, and then the value of I will be decrement. Then we'll test the controlling expression. Then the controlling expression find out the latest value of I is -1. It's not larger than 0. So that is why the do statement is terminated, and then print out the information here. But for the while statement, because at the beginning I is not larger than 10, so the statements inside the while loop body will not be executed at all. So you can see the only message printed by this example is this information. Okay, so that is all for today. Today we finished the rest part about selection statements. We introduced the concept of a loop and iteration. We introduced 2 iteration statements in C, that is while and do. And then we introduced the small difference between them and the biggest difference between them. And I believe for now you can you can write a program that continuously do something, and then that is also a core mechanism for the final project. So I will say that is all for today, and I will see you on Thursday.